most recently, I'm studying the hogfish, as you mentioned. These animals down the Florida Keys and coastal Florida, just incredible guys, and going out there spearfishing for them, just as a recreational angler, just having fun, taking them, spearing them in the Keys when season was open, throwing them on the deck of my boat. And one day I got up out of the boat after spearing, picked them up, went to go put them in the cooler, and I saw the side of the animal that was facing the boat hull had turned the color white and had taken on this pattern on the skin that was the texture of that boat hull. So if you've interacted with a hogfish, you might know that they have this incredible ability to change color. When I saw that day that perhaps the animal was, after it was dead, after I'd spearfished it, that its skin was still changing color in response to its environment, I was totally blown away. And since then, the last couple of years have been doing research on the side about how that color change happens and how they might be able to sense the environment with their skin. So it's a pretty amazing thing, both trying to use what I've studied out on the water, but also being inspired by those experiences back in the lab. I'm Dr. Lori Schweikert, and this is the Tom Rowland Podcast.
That was Dr. Lori Schweikert. She is a very interesting person to talk to. I really enjoyed having her on the show today. She is a researcher with degrees in marine biology from Florida. She's done a tremendous amount of research. And what separates her, in my mind, makes it a really interesting conversation for this particular podcast is she's not just a fish researcher, but she's also an active fisherman herself and gets a lot of inspiration, as you just heard, from her experiences on the water, bringing that back to the lab. And something is interesting, she goes back and studies it. She has questions about something, she goes back and studies it. Also, she has been able to apply her work to her own fishing on the water. I found it to be a great conversation, not only about the hogfish. Stand by, because most of the conversation actually is about the tarpon and how incredible their eyesight is. Tarpon are the superheroes of fish, as Russell Kleppinger called them. And as Dr. Lori Schweikert tells us, that is exactly right. They have incredible vision, and she's going to tell us exactly why. I had so many questions. About fish vision and what they can see, what they can't see. And in my own mind, I'm thinking, how can I apply that to catching more fish? So just one more thing about this podcast. I got so excited about doing it that I kind of messed things up on my end just a little bit and didn't hit the right button. So, still new at this. Been going just a little over a year. I appreciate you guys' patience. This one, the first 24 minutes, my voice is kind of a little bit distorted. A little bit. I mean, it'd be pretty good, I guess. But it's not up to my normal quality standard. So if you can just stick it out for 24 minutes, you will hear a noticeable improvement up to about the quality of my voice right now at the 24-minute mark. So I apologize for that, but stand by for an awesome conversation with Dr. Lori Schweikert.
All right. I have with me a very special guest today, Dr. Lori Schweikert. She's a marine biologist. She has a degree that she got in Florida, and she is also an angler. And what she just told me right before I hit record is that her passion is really marrying together the science and being an angler, right? Is that true, Lori?
Absolutely. Yeah, I think that the love of the natural world is what drives both scientists, marine biologists, and anglers. And through that, I'm able to really connect those parts of my life. Yeah.
That's cool. So did this start for you as a young person that you were interested in fishing, or how did you decide to go down this path in your education?
Yeah. So, I hear this a lot from some of my marine biology friends, that they just had these formative experiences growing up, and it really set the tone for them moving through their education, that's what they wanted to do. So I was raised on Long Island, New York, and did quite a bit of fishing up there with my father. And, he'd just take me out through the Hamptons, Shinnecock. We would just fish, and a lot of time fishing, maybe not so much catching, not to throw my dad under the bus, but just fell in love with the ocean, with the beach, with these animals at a pretty young age. And then had the privilege of vacationing in Florida, not only seeing what Orlando had to offer, but what coastal Florida and natural Florida had to offer. And from a young age, wanted to go into marine biology. And that's why I sought my degrees in Florida and have kind of continued my life here.
Yeah, that's cool. And so when you first think about pursuing that, I have two sons right now and another daughter that's in 10th grade, but my boys are both in college. And so we go through this college process of kind of picking a school and picking, they're expected to kind of know what they want to do. I think very few kids that age actually do. When you were kind of going from high school to college, did you have an idea that marine biology was what you were going to do from the beginning, or did that kind of happen after you had taken some classes in college?
I think that's a great question. I've been told that I'm a bit of an exception or a rarity to have so firmly known what I wanted to do from a young age, but I don't think that's necessarily the common thing or even the right thing. But no, I knew in high school I wanted to do marine biology. I had a real interest in behavior, what motivates animals and drives them to behave and survive the way they do. And I actually pursued a degree in psychology. And I say that because no matter what your degree is on early on or what your interests are, it's okay to change or kind of divert from that path. So I did get a psychology degree. It laid a lot of the foundation for what I study now, but I ultimately did make a little course correction, really going into biology, marine biology, and really embracing that. So I think part of it, there was a plan, and part of it was the journey.
Yeah, that's really interesting that you were kind of drawn to marine biology because of the behavior of animals, and that led you to the psychology. And when you study both of these at a high level, how much overlap is there between the behavior of animals like you and I and the behavior of animals like fish? Does that happen at all? Do you see any kind of overlap there?
Oh, absolutely. I mean, I think humans are set apart. I think that we are quite special and in our own ways. But at the end of the day, we're given the bodies that we have and the worlds in which we live, and trying to understand how an animal perceives that world and reacts within that world and is motivated within that world. Very simply, can be drawn a parallel whether you're a guppy in a pond or a person walking down the street. And that, I think, really ties me to why study sensory systems, why study vision. Maybe, the adage, you put yourself in someone else's shoes, you could really try to deeply understand them. And so doing it from that perspective.
Yeah, that's really interesting. And so that leads me to one of the big questions I had of this whole thing is your research, and I really don't know that much. I quickly did as much research on you as I could because my friend Jeff Arias attended a fishing club meeting that you spoke, and he was he must have sent me 2 or 3 text messages during your presentation saying you've got to get her on the podcast. And so I'm really excited about that. But what was interesting to him and became really interesting to me too was your research on fish vision. I'm sure you've done a tremendous amount of research outside of fish vision, but I wanted to talk to you today about fish vision. And just in the quick little bit of research that I did, I saw that you had referenced rainbow trout and tarpon and whales, and like you've done a lot of different. I mean, you know about not just one fish, but you've done a lot of different research on many different fish, right? Hogfish.
Yes. Absolutely. So, tarpon, all of it. Mm-hmm.
Yeah. So the tarpon, that's one that is for the audience that listens to this, that's one of the main fish that a lot of people go after, or one of their bucket list fish. Last week, I put a video on my Instagram, and it was of a guy in Mexico, and he had a sardine in his hand. And just like Robbie's in the Florida Keys or whatever, there were some small residential tarpon there. And he had this sardine, and he kind of held his hand out, and then the video went into slow motion. And as he pulled his hand back and went to throw it, you could see this one fish peel out before the rest of them. But it took off, and then the camera follows this sardine out, and you can see the wakes of the fish, and you can clearly follow this one fish that knew just what was going on and led the pack out there. And the moment of impact, it was no accident, followed the fish all the way in the air and eats it the second it hits the water. He didn't overrun it. He didn't underrun it. He didn't kind of go into an area where he kind of thought it would be. There's no question that he followed that, seeing it from in the water, and the fish is out of the water, and he follows it for 20 feet or whatever, and then eats it. And then that video, I check my DMs, I get 2 more videos that same day of, oh, look, this is what happens at our dock. And one of them was Jack Crevel doing almost exactly the same thing, and another was tarpon at Robbie's that are doing the same thing. When you throw a fish in the air, not only can these fish clearly see it, but they've also been clearly conditioned very quickly to this behavior of when the arm goes back, that means you go out and you can catch this fish before another one. The Jack Crevels are a little bit more aggressive. When I see them with tarpon, they usually get it first. But that there was so much interest in that with those 3 posts that I did right away. And that makes the timing of you coming on this podcast perfect. Because so what's going on there? Like, a tarpon clearly has outstanding vision, but it's a fish that is nocturnal at times, can feed in the daytime, can feed in the brightest conditions, but can also feed in the darkest conditions. They can obviously see really well. What has your research shown about the tarpon and his vision?
Yeah, so I really appreciate you bringing that story up. I've been down to Robbie's and I've seen it for myself, and you never quite get used to those animals. You're humbled by their presence, and certainly humbled when they jump up to eat a fish from your hand. I will say, I just love it because it's funny. It's the first thing I said at that fishing seminar that I gave recently, is that anglers and people out on the water typically know more about these animals before scientists do. And you can see them behaving in the real world and what they're capable of doing. And then seemingly, at least in my own experience, sometimes biologists come up years later with maybe the fundamental understanding of why things operate the way they do. So I just love hearing the stories and connecting that experience to the study. Tarpon are a phenomenal example of what fish visual systems can do. And fish vision generally is a topic of interest, of which I could build an entire career, or anyone could, because of the pressures that these animals face in their visual environment underwater. And we can certainly get into that. But to answer your question about what's happening there, a lot of vision has to do with the cells of the retina, and as well as like the size of the eye. We know tarpon with their large eye, their scientific name is actually Megalops atlanticus, or large eye of the Atlantic. And with that large eye and with their densely packed cells of their retina, they're good at seeing not only motion and contrast, but they have phenomenal color vision. And just using those in tandem there to localize that prey or see that prey item, and using its other senses to know where it is, struck the water, is going to make it a really efficient predator in its environment.
Yeah, well, they certainly are, and you don't have to fish for them very long to see that firsthand. That they can. They're just an amazing fish, and some of the things I had Russell Kleppinger on the podcast, and he had fished with some tarpon scientists, and they had done some different studies about, I don't know, I might butcher the story, but apparently there was one person that would feed these tarpon in a tank And when that person would come in, they would all go to this one part of the tank where they got fed. And when other people would come in, they wouldn't bother with that behavior because those people never fed them. And I don't know if that's possible or not, but it made for an awesome story that these fish were able to recognize either some sort of facial recognition or somebody's posture or just the way that, how quickly someone walked in the room or whatever it was. They were able to discern that it's time to be fed. And that's pretty cool. But the vision of the tarpon is also, it's hard for me to imagine that there could be a fish that could see much better and under so many different conditions: muddy water, clear water, dark light, super bright light, no clouds. But, they're obviously seeing out of the water. They're seeing birds. I mean, if you're fishing for laid up tarpon and a small seagull flies over a tarpon, it freaks them out. And they totally see that. And they're seeing the bird and not the shadow often. Like, it's one thing when a shadow comes over, then of course that scares them. But when they're seeing the bird or they see the fly line in the air, how is that happening? Because if we get in a pool and we look up, you're seeing kind of a blurry, if somebody's standing on the edge of a pool and you're underneath with a mask on, you look up and you can kind of see a blurry kind of figure up there. But I don't know that I'd be able to tell that his hand just went back and he's about to throw something. Could discern like how many people are up there or whatever. I mean, if you were really close to the surface, you could, but if you're, 4 feet down, that's really difficult. So our eyes obviously don't work like a tarpon.
Yeah, I mean, in my own research, not too familiar with in-air vision of tarpon explicitly. Animals that see underwater and in air, like amphibious animals like a frog, have special adaptations that allow their eyes to both be adjusted to how light behaves in air and how light behaves underwater. So, sorry about that. But with the tarpon, my understanding is that it is having vision that is fully appropriate for that vision underwater. Now, tarpon, relative to other fish, have my understanding to be truly outstanding resolution of their vision. So humans have pretty sharp resolution of their vision, able to make out objects, able to make out targets in front of them at about half of what birds of prey can do. But we still have, relative to other animals, we have pretty good sharpness to our vision. And I think that tarpon, with their cell density in their retina and the size of their eye, their resolution is close to what humans are capable of doing. And so that probably helps them between the water and air interface of being able to see things pretty sharply, at least relative to other fishes. And to do those things that you're saying, perhaps see someone chucking a fish or especially a bird coming overhead. You talked about tarpon living in this array of environments. From muddy backwaters, you can find them more riverine environments, or you can find them in an open ocean. And there's kind of two things going on there. The first thing is that with all fish having to deal with these different clarities and colors of environments, they have the ability over the course of life, we know across fishes, both to heal their retinas after damage and to change the function of their retinas, their vision, over life to adjust to the environments in which they live, right? That's very different from humans. We kind of have what we have, and our retinas are pretty static over time. But fish have this plasticity and can deal with these things.
So when you say they can heal their retina from damage, like what, that would obviously be useful because they're sustaining damage regularly, I guess. What kind of damage are they having to their retina that they would adapt that way?
Well, I think that may be more of a byproduct of the fact that when they're swimming in their life over depth from surface waters to deep waters or between habitats like muddy backwaters to open ocean, the need to be able to make the cells and the neurons of the retina plastic to meet those visual needs is what creates that regenerative or again, plastic ability of the retina. And perhaps a byproduct of that is their ability to heal the retina. Also, these animals tarpon spend quite a bit of time and can spend quite a bit of time in clear water coral reef waters is a lot of ultraviolet light scattering there, and that's hard on the eyes. So it wouldn't be of surprise to me that maybe part of their plasticity is then to deal with those detrimental effects of that UV light sensitivity in shallow waters. And so that's part of why I study fish generally, because of this plasticity, but also over the course of the day. You talked about their ability to see in all these environments. Tarpon have incredible night vision. Both many of the cells of the retina, rods that let us see at night, densely packed in their retinas. They also have eye shine, right? So like you'd see a deer on the side of the road, these tarpon have a reflective mirror in the back of their eye, using these things together to be really effective nighttime hunters. So yeah, they have a bunch of tricks up their sleeve that allow them to see the different times of the day, but then also at different times of their life.
So when you're learning all of these things about tarpon vision and other fish vision, what let's just ask this question: what other fish have you done significant research on besides the tarpon?
Done some research, a little bit of research early on snook and redfish vision, a bit on, and then also most recently did a massive review of the published literature about what is known about fish vision generally, where we're at in the field and kind of where we need to go.
Can you let us know? Give us a little layman's condensed version of that.
Well, basically, so let me just give you a little background first. Bottom line is, when it comes to your own vision or it comes to fish vision, it's half of this equation is the light that's available in the water and that's present in that light environment, right? If you're swimming in Lake Okeechobee or you're swimming off the Keys, it's going to be a completely different light environment in that situation. So that's half of the equation. The other half of the equation is, again, what your game fish of interest is able to see. And the animals that live in these different environments, you can bet, have visual systems that are adopted well to see under the conditions in which they live. And so basically, fish have the most diverse color vision ability of all known animals. You have fish that see in black and white forever, very high sensitive vision, and you have fish like the tarpon that have color vision that far surpasses our own ability, being able to see colors that we can't even imagine, such as those in the UV, and such as colors or light associated in the ultraviolet. And doing my research, sweeping across all known fishes of what they're able to see, on average, many have kind of a color vision ability similar to ours. What we have is called trichromatic vision, where we have three types of cone cells in the retina that allow us to see all the colors of our visual world. And that's the majority of the fish have this trichromatic vision, a lot of sensitivity over the blue wavelengths, right? That makes sense with our blue oceans, our blue waters. And then you have outliers of what we know in fish. And some of the outliers, like the tarpon, having 5 cone cells, extraordinary color vision ability, and again, bleeding down into those ultraviolet wavelengths. So it depends on where the animal lives and what it would require that vision to do, which really talks about what their abilities are.
So when you say it depends on where the animal lives, is that like where the species could possibly live? Like take a tarpon, for example. We can find tarpon that they're up in the 10,000 Islands. It's very muddy. You have muddy rivers in Costa Rica that have tarpon, or you could see them in Key West on a white sand flat where the water is crystal clear. So the species is going to live in a lot of these different areas. That particular fish might not, but he still maintains all of these qualities in his eyes. What you're saying?
Exactly. I mean, some specific examples of where a fish lives, like across depth, right? So if you're fishing for tarpon that can be found in shallow waters, above coral reefs, fishes on flats, they're exposed to all the colors that are available within sunlight, right? As opposed to fish that are at great depths where sunlight is powerfully filtered. There's only essentially blue light to support their vision. And so, for example, over depth is where across different depths are where it's going to determine the fish visual ability. And just like you said, across habitat, we studied tarpon color vision over their life cycle, over their different stages, and the juveniles, the young of year, that live in these really muddy red backwater environments, we see them have very good color vision over that red end of the spectrum, less so over the blue. And as they migrate into these coastal waters and then eventually offshore to spawn, they have this giant shift of their sensitivity over to the blue, violet, more of the green end of the spectrum. So where they live and depth and habitat really matters.
So that's kind of what you're talking about the repairing of the retina, that they're able to, the plasticity, that they're able to go from this red type environment into this blue type environment and change their eyes.
Absolutely.
That's incredible. That's incredible, because you just wonder, like, I mean, it's just so obviously different. And that's a very good explanation. I mean, when you have that tannic acid coming out of the mangroves, the water is red. It is red. And they can see every bit as clearly as they can see in perfectly clear water. And apparently, on a dark night, in Key West Harbor, they're blasting crabs and shrimp. They can see that perfectly because it sounds like a war. And I've just always been amazed at the tarpon's vision. Now, what about largemouth bass? Have you done any research on the largemouth bass?
I have not specifically, but I have some colleagues that are looking into that now. And just as you would expect, these animals living in these more of these inshore environments, having more of this sensitivity to these redder types of wavelengths. And it's important to understand why color is so important, why I keep bringing it up. The bottom line is vision and air, we all understand. Okay, we're all familiar with. There's a lot of light up here, a lot of different colors for our eyes to see. The light we experience on a day-to-day basis is fairly predictable. But underwater, again, water acts as this powerful filter of intensity and color. And, white light, sunlight is made up of all the colors. And as white light is passing through that water column, whether you're in the environment of a largemouth bass or environment of a tarpon, it kind of works the same. You have all the colors available at the surface, but then red light is lower energy light, gets filtered out very quickly, and you have just blue kind of penetrating to depth. But that's not the only thing. Like you mentioned tannins, you mentioned runoff. The other half of what determines the visibility of water and the coloration of water are ecological variables like algal blooms or turbidity, mixing up of the sediment of the bottom. And so it's these factors together that kind of drive that background light environments in which the fish can see. So yes, they need to be very good at seeing the colors and seeing at the brightness that's available in their environment, because vision's life or death. For them, it's either to get that prey and survive, get away from that predator, or to find their own mates and to move on that way. And so where our eyes would fail in these environments, theirs have overcome.
That's really interesting. Well, the reason I ask about largemouth bass is because there's no fish on the planet that has more lures of every conceivable color, design, shape than the largemouth bass. I mean, if you go into Bass Pro Shops, there is literally colors I've never even seen before. So when you look at that and you're like, okay, is this really necessary? Like, all of these different colors, but when you think, okay, I mean, sometimes I'm just looking at that. I'm like, well, that's obviously there to catch a fisherman more so than it is to catch a bass or a tarpon or a grouper or anything else. You have the lures that are kind of designed to catch a fisherman. They look cool. They have a nice design. They're shiny or whatever. But now when I'm listening to you talk about how important the vision is, when you go into Bass Pro Shops and you walk down the aisle there and you see this vast array of colors, do you think this is completely unnecessary? Or do you think, wow, these guys really seem to know a little bit about what they're doing here? I mean, what about that? The millions of different color lures. What do you think about that?
I love that. I just got to bring up the example. that, one thing that you've seen kind of hit the market is UV reflectivity of lures. And there are tons of fish that can see UV reflectivity, but UV light, despite that it's so powerful, by its nature, it doesn't penetrate to depth very well. It scatters very quickly in the water column. So basically, if you're out there and you've spent money on a UV reflective lure and you're casting it down to great depths, okay, beyond just a couple of meters, you're not utilizing any UV reflectivity down there. It's simply not down there, maybe to reflect off that lure. So, I mean, bottom line is, I think there's science behind lure visibility. I think that there's a lot of experience by it, and I don't want to downplay any of that. But at the end of the day, I think we have to be careful on what's simply just marketing and maybe what's not so important. In terms of the bass, they're in these, in my experience, what I've seen, these pretty, what are not so clear environments, very red shifted environments. And so using this vast array of color, is it really playing to their color vision ability, or is it just simply that you need to have a dark silhouetted lure in the water column that they're able to visualize against that background light? Maybe at that point, it's less about color, but more about contrast, more about that movement or sound of that lure through the water that's really driving them to hit.
Now, I've always kind of thought that maybe, we create all these lures like chartreuse, and, if people say if it ain't chartreuse, it ain't no use. And we're fishing chartreuse on the surface and we're fishing chartreuse down deep. And I've always kind of thought, well, just like you were talking about, I don't really know how a fish sees. You're obviously going to think differently because you have a much greater understanding of how a fish sees. But I'm thinking, okay, well, as the color, you'll see those charts of what, red will look like at 50 feet or whatever. And it's just black, right? Or these other colors, you take this color wheel down as a scuba diver or whatever takes this color wheel down, and you see all the different colors at 50 feet or 100 feet or all these different, and they just look like various shades of gray and black, right?
Absolutely. Yeah. So, I think one of the, sorry, go ahead.
Well, what I was thinking is, like, as you see these lures that, somebody like Kevin Van Dam might fish a very similar lure to everyone else, but it might be a new color. And for whatever reason, they eat it, and they're not eating the others. But it's so, instead of yellow, it's chartreuse, or instead of blue, it's black, or some sort of little different color variation. But I've always kind of thought, well, how deep is he fishing that? Because maybe it just looks darker or lighter, or that was what you were saying, is like maybe it's just a darker silhouette, and these colors that look so interesting on the shelf, how are they going to look at 15 feet down to a tarpon or a redfish or a grouper or whatever you're fishing for? And maybe all those colors are necessary because they don't look like that where you're fishing with them.
Exactly. And I think I will say one of the largest misconceptions, I think, for understanding underwater light and lure selection in angling is that red reflection at depth, red light or red colors at depth doesn't mean that they're harder to see or become invisible. It simply means that there's no red light at depth to reflect from that lure, and thus it looks black. Okay.
Black.
And so really
Yes.
something red at depth, again, because there's no red light, someone might think, oh, maybe it'll be more invisible or hard, more camouflage or harder to see. It might even be more visible because it looks black. It's darker against that light background. Right.
That's what I'm so glad to hear you say that, because there was a red line that was popular for a while, and I just never bought into it. I was like, yeah, but it's not going to be invisible. It's going to be black. I don't want black line. If I wanted black line, I would get black line. Like, I want clear line or invisible line, actually invisible line. So red doesn't disappear. It just turns black. The red part disappears.
Exactly it. That's exactly it, right? You think about if you're on the boat, you wear a white t-shirt, you want to be cool, you want to reflect all that light off you. That's all the colors coming back. Black is just it's the lack of reflection of that color. There's no light coming back to your eye. So red color depth, that's what's going on.
And you think that the fish are seeing that just the same? The construction of our eyes and the fish's eyes are similar enough to where we can make the correlation to say if we see it black at depth, then a fish is seeing it black too.
Absolutely, because black is the lack of light reflecting back to that eye. So whether it's a fish or a human looking at it, black is essentially going to be black. And it's something to think about, targeting colors and targeting certain colors at certain depths for visibility. And what I've come to learn from my own experience out in the water and talking to anglers, it's maybe not what's most visible to the fish might be what they're most likely to hit, but what might be more akin to what they're naturally interested into in the wild. I mean, you think about if they see something totally bizarre down there, something that doesn't even look like their prey or act like their prey, just because they can see it very well, maybe not be what they're going to hit. So that's something to keep in mind too. Maximizing visibility may not always be the key to being the best angler, but it's something to keep in mind if you want them to see their prey or see that lure at a distance. Maximizing visibility is all about increasing color contrast. Okay, so if you use a red lure in red water, it's going to be harder to see, right, than if you're using, let's say, a white lure or something that's going to have a broader spectrum of reflectance than just that matches that background. So color contrast, brightness contrast. You want to see something, it needs to be either darker or lighter than background. It needs to differ from background. So maybe a really reflective jig in the face of in these waters might be more useful than one that's just matte that might appear the same as background. And also size, again, because I said fish have lower resolution vision on average. You think about seeing an eye chart at a doctor, fish are going to not do so well relative to ours, having about half on average of the resolution of our own vision. You're going to want things to be big enough for them to see at a distance. And then the inverse is true. As much as we care about them seeing our lure, seeing our bait, we care about the fish not seeing our own rigs, right? Not seeing, like you mentioned, these using lines in the water, fluorocarbon. These are things that are of equal importance to how successful we'll be out on the water.
Mm-hmm. And so as you're, going down this path of all this research and learning more and more, you're also spending more and more time on the water and you enjoy fishing and you're a good angler. How much are you taking out on the boat with you? Was there a time where you're kind of like, well, I don't know why this lure works or whatever, but they should be able to see all this hardware and stuff. If we took all that off, then maybe we'd catch more fish, and then it works because of your research. Like, have you had a couple of situations like that where you start learning something in the classroom and think differently about it and then go apply it on the water and it really works for you?
That's an interesting point. I mean, absolutely. I will say with the tarpon, particularly, I've hooked up on tarpon. I've had them spool me. I've never landed one, which is kind of a sad thing to say. But talking about selecting artificial for that animal, for that mature animal, I knew the extreme sensitivity that they have over the blue and violet range, and so selecting purple mirror lure, purple artificial out there to try to target them has been my key. I use as small diameter leader as possible, as long leaders as possible. I try to put my weights on the line to keep them where they're maybe not going to be so visible to the animal, and really try to use some of what I know out there. At the end of the day, I get far more inspiration for my work from being out there than I am to even apply it, my own work. One example being, most recently, I'm studying the hogfish, as you mentioned. These animals down the Florida Keys and coastal Florida, just incredible guys, and going out there spearfishing for them, just as a recreational angler, just having fun, taking them, spearing them in the Keys when season was open, throwing them on the deck of my boat. And one day I got up out of the boat after spearing, picked them up, went to go put them in the cooler. And I saw the side of the animal that was facing the boat hull had turned the color white and had taken on this pattern on the skin that was the texture of that boat hull. So if you've interacted with a hogfish, you might know that they have this incredible ability to change color. When I saw that day that perhaps the animal was after it was dead, after I'd spearfished it, that its skin was still changing color and changing color in response to its environment. I was totally blown away. And since then, the last couple of years have been doing research on the side about how that color change happens and how they might be able to sense the environment with their skin. So it's a pretty amazing thing, both trying to use what I've studied out on the water, but also being inspired by those experiences back in the lab.
Yeah, that's very interesting. You talk about changing colors like that, and that particular fish was able to change just one side of its coloration. I've never kind of thought that or correlated that to vision, like that is associated with the vision. But I did see that was one of your things, is like skin. I mean, it was in quotes, skin vision on the hogfish. That very similar to what you were just talking about was part of your research. I always kind of thought that they were just able to, make themselves more camouflage. You'll see redfish that will become almost snow white if they're over white sand bottom versus, or like a mutton snapper. You can have two different mutton snappers, one caught on grass, one caught on white sand. One is almost blonde or white, and then the other is very dark colored. But you're saying that could also be part of how they're seeing, like, and how the photoreceptors in their skin are changing with their eyes, almost like they're putting on sunglasses at times, I would imagine. Like if it's super bright and you have the same fish that's in a darker, or the same type of fish that's in a darker environment, he's able to see perfectly well and hunt and very efficiently. But then that same species can live in a very bright area and do the same. And you're saying that has something to do with their skin as well as just their eyes.
Yeah, with these hogfish particularly, but we're finding with other fishes, with fishes that change color and pattern to hide in their background environment, that they're using their eyes, to understand where they are. I'm on open sand, or I'm on rock rubble, or I'm over gravel, flounder, and then to know where it is and that a predator's coming, I need to hide. And we're finding more and more that these animals that color change like that have this sensory system in their skin that is sensitive to light or receptive to light. And it's thought that they're using this quote unquote skin vision to help them effectively change color under those different conditions.
That's fascinating.
Yeah.
What do you think is happening with the mahi-mahi? Is anybody researching those? Because I don't think there's another fish that changes color as quickly, that is a game fish that people go for so much. But I mean, those things will come in and they'll be blue, metallic looking, and then they'll go to the classic green and yellow, and then they can be, not that brightly colored, but they can go through the widest color change of any fish that I think that I've seen.
Yeah, they're unbelievable how they light up right before they strike a prey. I mean, they're incredible animals in their ability to change color. And a lot of pelagic fishes, the billfishes, have this ability to strikingly change color, become iridescent, become darker, become lighter in very short time scales. I'm not studying that explicitly. I think it still needs to be studied in more detail. But I would not be surprised if they're employing a similar sensory system as these hogfish or color changing flounders are, that they're having the skin itself acts as its own sensor for their color change abilities. I mean, there's not a lot of places to hide in open water, right? And so these animals having this phenomenal vision to be able to see predators at a great distance, ability to change color, to try to hide in with their surroundings, they're just pulling out all the tricks to try to survive in that open environment.
Yeah, I mean, you would think, kind of on one hand, you're thinking maybe a dolphin is changing colors to hide from what he's trying to eat, but on the other hand, even a 20 or 30 pound dolphin is by no means top of the food chain out there, and they're all manner of things. So while they're going to hunt other fish, they're also putting themselves at risk of being hunted themselves. And maybe they're changing colors to protect themselves as they're, leaving the school or whatever. I never thought about it like that. Like maybe could possibly be something that's going on too, is they're going to that blue color to match the sky so that they're not as visible to the marlin that might feed on them, or I don't know what's going on, but there's obviously a lot more going on than we're once given credit for these fish, with their vision, with their skin, with what's going on in their ability to change colors. So for that point, where does your research go from here? Like, what are you excited to study? Are you going to go further into fish vision? Are you going to take some of the things that you've learned here, and that kind of opens some curiosity to some other fields? Where do you go from here?
That's a great question. And of course, I think as scientists, we all have a plan, and then we're just inspired as we have experiences as we continue to go forward. We talked about this extreme light environment that fish have to survive in, and some adaptations of their eyes to be able to survive in that environment. Light can be very limited in an underwater environment, and especially as you get to great depth. And so another branch of this story that I am moving into with my research is the role of bioluminescence, or the natural ability to create light underwater, and how that has to do with marine animal ecology. I had not known this, but when I had given a talk at the fishing seminar the other day, there were gentlemen who were talking about how they're using these underwater light beacons to attract billfishes to their lines. And it's very interesting to me. That's very reminiscent of maybe what some of these animals are going to encounter in the water, as so many organisms in the marine environment can create and emit their own light of different colors and different intensities. So my research at Florida International University right now is going towards that branch of it, which is this emission of light and how that could be perceived by predators and by prey. So.
Well, certainly in the sword fishing world, I mean, those guys, it was thought, for a long time when everything was nighttime sword fishing, that it was all about the light. They had these big lights on the surface, and there were lights all up and down the leaders. Now things are streamlined. They're catching these fish in the daytime. Obviously, daytime sword fishing is really popular now, and obviously catching lots of them. But the lights, first of all, the lights have gotten better. They've gotten smaller. They can handle, going down into the depths. But I mean, you'll talk to some of the captains that are big time swordfish captains, and they wouldn't even put a bait down without a light on it. And others don't feel like that, just like every other type of fishing. Whatever it is that someone feels strongly about, there's another fisherman or captain that feels strongly the opposite way, and both seem to work sometimes. Which is also kind of interesting as it comes to fishing. But that bioluminescence is probably something that could be studied not only at depth, but we see that stuff like in Key West Harbor when we're night fishing for tarpon. There's all of it. It's all over the place. Very, very cool looking. I don't know if it has anything to do with the way the tarpon are feeding, but I'd like to know what it is.
Exactly. I mean, I've had the privilege of going bioluminescence kayaking and so forth, and you're just out on the water in those warm end of summer months, early fall, where that water's so warm. You get this bloom of what are called dinoflagellates, or these these plankton in the water that, when they become agitated, emit this beautiful blue-green light. And being out there on the kayak out there in these Florida backwaters, and spooking schools of mullet with my kayak, and seeing the whole school and dart left, dart right, and just seeing these streams of light in the shape of a fish. It's hard to think how the predators are not so effective during those times. I mean, this blue-green light does fall in the direct color sensitivity of many fish, including the tarpon. So it's going to be making these prey in these shallow waters more visible. At the same time, as you have a predator moving through the water, they then become more visible to prey at a distance, right? You see this big glowing mass coming at you from a distance. And so that really, I guess, complicates it for these animal interactions under those circumstances.
That's kind of an interesting thought there. Earlier, you were talking about how tarpon can see so many different colors that are invisible to us. Would it be a stretch to say that, a shrimp in the water and a dark night on the water is creating some types of light that are invisible to us, but incredibly visible to the tarpon? I mean, we assume that a tarpon has this incredible night vision, and they can see shrimp on a black, dark night. But could it be that maybe there's some, bioluminescence that's getting agitated, like you say, like what you were talking about on the mullet? That's very obvious to you. But is it possible that there could be some sort of light on the spectrum that we're not seeing, that the tarpon is seeing very clearly?
I mean, potentially. I think potentially. I mean, there's another phenomenon that's called fluorescence, and you've probably seen this yourself. You put a black light maybe over your chartreuse lure, and you'll actually see when you have that certain blue light going on there, you have this emission of greens coming out of your lure. That's called fluorescence. It's reactive. It's not the generation of light, but it is the emission of one color of light under certain conditions. And we're finding so many marine organisms are also fluorescent. So when these shrimp are getting lunar light or moonlight onto them, they could be fluorescing at certain colors that the tarpon are picking up as well. But you think, I almost get this vision evoked of the Predator movies, right? With Arnold Schwarzenegger, you see this incredible night vision ability to see a target in the background. Tarpon, with their extreme sensitivity to light at night, are probably able to silhouette these prey against that background moonlight far better than we're able to. So that's playing a role too. Plus, they're able to smell their prey and so forth. So it's this whole combination of things working together.
Yeah, it's fascinating.
Yeah.
Okay, one more question about a different fish. Have you ever had an opportunity to study the bonefish and its vision?
Bonefish are closely related to the tarpon. They're in the same order. I have not, but I had a colleague who did. So just as you would expect, they're shallow water species, clear water species. I think they have complex color vision, right? We're on par with us, but their color vision does not marry to that of the tarpon. Again, with these 5 cones that let them see fairly broadly. But yeah, so it's in the work. It's been studied and definitely been tried to be tied to their trying to better understand these fish, their ecology, and to conserve them.
Yeah, that's important. But the first bonefish that I ever caught, it was pointed out to me that they were wearing goggles. And I kind of looked at this fish, and if you look at a bonefish from the top down, they are essentially wearing a scuba mask. They have a membrane that goes over their eye, and unlike the tarpon, unlike the snapper, unlike the amberjack or any fish like that maybe you're familiar with, you can't touch their eye. Mm-hmm. You can run your finger over the top of this lens that goes over it, but you can't touch their eye. And I was just kind of wondering, like, how or why does a fish adapt like that? I mean, obviously a bonefish is mudding. They're going down into these holes. They're putting their eyes in the mud. So I guess over time they just kind of adapt this lens that protects their eye and allows them to see in those conditions where they're literally have their eye in the mud. Is that what's going on there? Or are there other fish that have that kind of membrane cone, kind of lens across their eye?
I think you've hit the nail on the head. I've also seen, I know exactly what you're talking about. It's pretty thick, right? This thick, clear membrane just essentially protecting the layers of eyes. We also see that on mullet. And so the connection there is mullet are eating what we call detritus off of the bottom, dead matter, decaying matter. They're down in there rooting around, also foraging off the bottom. I wouldn't be surprised if that membrane exists such that to protect their eyes, as it potentially would with the bonefish. And you're right, you don't see that broadly across other animals. You think about the tarpon, it has this beautiful upturned jaw, and they're very much attack their prey from beneath, ramming beneath them and capturing their prey. And so they're looking above. They're less so, maybe perhaps less often eating within the sand, eating off the bottom. And so they maybe not needing that membrane, maybe just to be able to see kind of in that upward line of sight. And in fact, once we study their retina and study their ability, we see that their sharpest visual ability is in that upward direction. So just like our own eyes, we have you have central vision and then you have peripheral vision that's not as sharp. Tarpon's central vision really is in that upward line of sight. And so that it's that sensory biology, again, marrying to ecology, how are their bodies built and how does that building plan really inform us about how they survive in their environment.
It's interesting when you kind of apply that to another fish like a redfish or something like that, that is kind of a combination of the two. Like it has this downturned, it often feeds down, but its eyes don't have the lens over it like the bonefish does.
Yeah.
But it'll also feed up and has particularly good vision that way too. That seems like a interesting fish to study. You said you had done some redfish research, right?
A little bit, and that is ongoing, and it is really interesting. Yeah, right. They have these mouths on the bottom, and they can't eat off the bottom. But I'll tell you, some of the most amazing experiences I've had on the water was topwater fishing for redfish using pass crabs in Sebastian Inlet, and man, can they see those crabs at the surface and just roll on top of them and strike them? It's incredible. And so yeah, it'd be interesting to see what's happening there with their eyes.
Yeah, I mean, how would you know, like when you say that the tarpon, that you've done the studies, or there's been studies done where you can clearly see that they are most visually acute at the looking up like that? How can you tell that? Like, and you would be able to tell that a bonefish maybe is best looking down. Is that part of the eye structure, or how would you know that?
That's a great question. So bottom line, just like in our own eyes, one key indicator of the sharpness of vision in a certain direction is the density of rod and cone photoreceptors in that retina. So if you take a fish retina, you look at it under a microscope and you count cells in the different regions, the streaks where you have the highest densely packed area of cells is what's indicating to you the direction in which they have pretty focused vision. So for fish, they have, and so that's exactly what's going on. So we have a fovea. We have an area in our retina where we see very sharply. In those terms, fish also have a high density of cells.
Wow, that's fascinating.
Yeah.
That's really cool. Man, there's so many questions and so many things I'd like to learn. I really want to have you on again, especially as we get some particular subjects on different fish that you could help us with to understand just what's going on there. But this has been amazing. I mean, the research that you're doing is really cool. I have one following question about the research. Like, one of the challenges to any research, I would imagine, is getting it funded. So on a study like fish vision, is there a particular fish or a particular direction that is kind of the path of least resistance, or do you have the ability or freedom to kind of study any particular fish that you want? Is there a path of least resistance to getting the funding to do the studies that you want to do? Yeah,
I really appreciate that question. Absolutely. I mean, the bottom line is that scientists or anybody, who are trying to get funds and support to be able to ask the questions that they'd like to ask, have a responsibility not only to pick things that are interesting and inspiring to themselves, but also something that generally can benefit society, will improve and advance our knowledge, that could be leveraged for other fields that are important. And so studying fish vision is something that can be very well supported, both by people and by funding sources. And because nature has already done what is hundreds of millions of years of research and development, right? And over that time has really curtailed the designs of certain systems that work very optimally in our world. And so by simply studying something like tarpon color vision, which you can ask, and by the way, which you ask in a live animal, you put an electrode on a sleeping tarpon's eye very gently, same as you would do with a human, flash different colors of light into their eye and see what they're able to see, right? That figuring out that they have what we would call hyperspectral vision, so it's incredible color vision, might one day allow us to build and design a better underwater color sensors for our own technology. Or trying to understand, for example, how an animal like that changes the structure and the function of its eye over life and regenerates it after damage. How maybe we could leverage that to try to improve or repair our own vision. or to cure people who have had degeneration of their own retinas. And so, we look to nature, nature's already found so many solutions to our problems, to then try to improve our own. And so, that's what keeps us motivated, and that's the end goal.
Wow, that's fascinating. That's really cool. Because, oftentimes you may have certain research that will be for a particular food fish or something, along those lines that, we need to know this so that we can, sustain the population or fish for them, more effectively, or understand kind of how many, what's sustainable or whatever. And then a fish like a tarpon or a bonefish kind of doesn't get studied. And that's why I was interested in that, because they're, don't really have food value, but they do have high economic value. And I just kind of was wondering what led you to those fish. But what your response was awesome.
But what you said is completely true too. Yes, they're economically important fish. They're also ecologically important fish, being major predators. And so for understanding fish biology, to then understanding how they survive, to then be able to improve their conservation is by far is an underlying theme.
Mm-hmm. And have you had any communication with Bonefish Tarpon Trust or any of the conservation groups that are tagging and doing different studies on tarpon? Do they look to you for some of your research?
Absolutely. I mean, I've had the privilege to essentially go to them, really, and I gave a talk in years past at a meeting of the Bonefish Tarpon Trust. And we talked about how what I know about these animals' sensory biology, how that kind of adds to the web of what we understand for these animals. And so I know some folks there. They're doing some phenomenal work, particularly, I think recently trying to understand, improve bonefish stocks, perhaps be able to potentially aquaculture these animals. And I've connected with them, and we're familiar with how our work all ties together.
Wow. Well, it's fascinating. I love all of your research, and the fact that you're an angler and bringing it and applying it out there for yourself on the boat is the best part of the whole story for me. But I as an avid angler, I'm always trying to learn more about the quarry, and this has been great. I mean, I learned a bunch. I'm sure that the audience did as well. I'd love to have you on again. And also, as we spoke before, I'd love to do a feature on saltwater experience on Fish Vision at some point. So we'll work on that, and maybe we can get that done for next year. But just want to thank you for all the research that you're doing and for taking your time out today to be on the show. And if people want to follow you and learn more about your research, how would they do that?
Well, you could just Google my name. I'm fortunate to have a very unique name there I married into, and my information will come right up, both on my email. I also have a Twitter at Lori Schweikert. Okay, and I would love to hear your stories, your anecdotes out on the water that you've seen with these fish. Questions you want to know about their ability to see the things you want them to see, or to hide the things you don't want them to see, and just be able to answer your questions and to learn from you. And Tom, this has been phenomenal. I've had so much fun. Would be very happy to keep this conversation going.
Great. Well, we'll do it. I always have lots of questions, and people write in all the time and ask questions too. So next time that we decide to do a podcast together, what we'll do is put it out to the audience that we're going to do this, and I'm sure people will have some very specific questions on Fish Vision that maybe we could answer or at least attempt to. So anyway, until next time, thank you so much for being on the podcast. I really appreciate it, and we'll do it again.
Thank you.
All right. Bye.
Bye.